All right, welcome back to Genius. So in this section, let's take a look at primitive and reference types and data types in Python. Now, the reason why I'm bringing up this section first is because we are supposed to talk about deep shallow copying, and we are supposed to talk about shallow copying and deep copying. And if we don't understand what primitive and reference types are, we might not really understand how everything works. So I deem it fit to bring this one first so that you get to understand what we are talking about. So what is primitive and reference types in Python? So in Python, data types can be broadly categorized into primitive or immutable types and reference or mutable types. So in Python, of course, in computer programming, in your computer, we are actually working with data. And we all know what data types are. So a data has a type, and a data type is the type of that data. So it is broadly categorized or divided into two: primitive and primitive types. They are immutable. It means that they cannot be changed. If you create a primitive type, you cannot change it. It is immutable. While reference types are mutable. Okay, reference types are mutable. So you can, when you create them, you can actually change them. So when you understand the difference between the primitive and the reference types, all right, it is very crucial because it affects how variables are stored, accessed, and manipulated. So when you understand the difference between primitive types and reference types, you're going to understand all the variables that you're creating when you're manipulating data, when you're manipulating the variables. You will understand the effects, all right, all those things you're doing have on them. So let's take a look at primitive types. Where they are immutable, meaning that their values cannot be changed. Their values cannot be changed after you have created them. Okay, so instead any operation that that appears to modify an immutable object actually creates a new one. So when you create a mutable object, an immutable object, you say like you create age equals to 30. All right. Once you have created it, you cannot modify it. Like it is immutable. You cannot change it. Sometimes when we now say age is equal to 35, when we will reassign a value to it, we think that we are actually modifying it. No. Python is creating another object. Okay, don't worry, I'm going to explain to you better. Okay. When you create a variable and later on reassign a value to it, Python is going to create a new one, but you will not know. So Python will create a new one, then the old one will still be in memory. So that is why when you're working with this data types, you should be very careful because as you're reassigning and modifying those variables, the new ones are being created, and the old ones are in memory, and they are actually making your memory full. Okay. So what are the common primitive types that we have in Python? Integers are primitive types. Floating points are primitive types. Booleans are primitive types. Strings are primitive types. Okay. Tuples are primitive types. So whenever you create any of these data types, if you create them and you try to reassign them, Python is creating a new object altogether. So let me show you something. Let's see an example of immutability. So when you do this, s is equal to 5. So you have created a variable and you have assigned 5, all right, to it. So this is an integer variable. So when you now, if you print, there is a function called id. The ID of a function, this ID will actually give you the memory location of that variable. Remember that variables that you create, okay, they are actually the address location, the memory location of that variable. Okay, so when we do something like this, okay, look at it. Okay, let's go to code. Let's go to code. So I open my Visual Studio Code. Now, let me show you that whenever you create things like that, Python is actually making changes. So if I say x is equal to 5, all right? And then I will now say, let's print the address, the ID. Now, this ID function, all right, is going to print out the memory address of this variable. Remember that this variable, all right, I am storing 5 in a memory location, all right? Then I am telling Python, okay, use this X as the name of that memory location. Whenever I want to access this value that I have stored in the memory, I will use this variable name, this identifier. So if I say print ID of X, this ID is going to print the identity of that object because this has created an integer object. All right. When you do something like this, it has created an integer object, and that integer object, the address is stored. All right. The address is stored. So this is the reference to the address. So this is reference to the address. So if I say, oh yeah, give me the ID of this object, oh yeah, give me the identity of this object. The identity of the object is basically the memory address. Where is this object stored in? So if I print this, if I run this code now, look at the address, look at the memory address. Okay, look at the memory address. This is the memory address. Okay, now what it means is this 5 that I have here has been stored in memory address. Just like now, everybody has an address. You have a house address. Okay, if I want to look for you, I'll go to your house address and look for you. So if you want to look for this value that you have stored, all right, you will go to this memory address. So this is the ID of this object that we have created. So when we do this thing, we created an object in memory, and this is the ID. Okay, so when we do something again, if we now say X is equal to, if I do S plus equal to 1, I believe you understand what this operator is doing. We are actually adding 1 to the value of S. So the value of S will now be 6. So if I now say print ID of X, now look at it. We are printing the first ID, we are printing the second ID. So here, when we created this object, we have this ID. And when we now modify this object, Python is going to create a new object. And that is why the second ID is also going to be different from the first one. If I run this code now, you're going to see 2 different addresses. You can see it, they are different. This number is different from this one. Okay, I believe you can see this very well. All right, you can see this very well. Okay, you can see that the addresses are different. So when we created this object, all right, Python created a memory space for it, then stored this value 5 in it. Then when we now modified it, Python created another object that now has a separate ID. So immutable objects, immutable data types, strings, integers, floats, tuple, booleans, when you create a variable of them, Python creates an object, a new object. If you modify it, Python will create a new object. So basically, you are not modifying the old one. Python is creating a new one. All right? So that is why we call them immutable. But for us, we think that we are actually changing them directly. So when you do this, you're going to see that we have a different memory address. So Python is, whenever you modify this variable, Python will create a new object, create a new memory space for it, and add it there. That is why we have a new memory space, a memory address. So you can see that the memory address of the first one is different from the second memory address because a new object was created. Then if you have something like hello, all right, which is a string, and you print the memory address, if you now add word to it, Python is going to create another one. Python will create a new object. And now we created this object. Python created this object for us the first time. When we modify the Python created another object. Now this one is the object now we are working with. The old one is still in memory. So when you're doing things like this, your memory will keep getting full because you're having new objects being created that we are not flushed out. So you see, we are going to have a different memory address here and a different one here. So let me also show you in code. So when I go on and I would say y is equal to hello. Okay, y is equal to hello. And I print the memory address, ID of y. Okay, and I come back, I say y is equal to plus equal to world. So I'm going to have hello world. So if I print the memory address, it's going to be different from the one I have before of y. So maybe I should just comment these ones. I will comment them. Then we only have these ones to work with. So I will say print, I will say first memory address. First memory address is this. Oh, sorry. I'm actually writing JavaScript here. I'm so sorry, guys. I thought I'm writing JavaScript. I'm using the template literal. I should use the... Oh my God. It's okay. All right. When you're writing multiple languages, that is what you get. So here I will be saying second address. I will say second address. Okay, second memory address. So when I run this code now, okay, let me just clear here. Let me clear. Then I will run the code again. You can see the first memory address is this, and the second memory address is this. They are different. Okay, they are totally different. So the first one you created, Python has it in memory. Then when you now modified it, Python did not just modify the old one. It created a new object. And that is why we have a new object in a new memory address. So you have to bear this in mind, okay? All right. So when you change the value of S, a new object is created rather than modifying the existing one. I've explained this thing enough. So strings also follow the same behavior. They do the same thing because they are all immutable objects, okay? So why does immutability matter? Why did Python actually include this immutability in primitive types? It prevents accidental changes. You can see now that if I accidentally try to change a primitive value, Python is going to create a new one. So I'm not going to change it. So that one will not be affected. The old one will not be affected. Okay? The old one will not be affected. It makes objects hashable. This might be a little advanced for you. Then it makes them hashable, allowing their use as keys in dictionaries or elements in sets. Okay, because they are hashable, I'm not going to explain what hashable means. When we do advanced Python, we are going to be explaining that. But just understand that it makes them hashable, allowing them to be used as keys in dictionaries and or elements in sets. It enhances performance in multi-threaded environments. All right. So these are the benefits. Okay. It prevents accidental changes. You don't just change values accidentally. It makes them hashable and it makes them to be, you can use them as keys in dictionaries. Now, this is the reason why in dictionaries, the keys of dictionaries you can use tuples as the keys of the dictionary because they are immutable. Dictionary keys can be tuples, it can be integers, it can be Boolean, it can be strings, okay? It can be floats too. So what about reference types? Now, these types are mutable. It means that if you create a reference type and try to modify it, you'll be modifying the original one, all right? So they are mutable, they can be changed. So reference types are mutable, meaning their values can be changed without creating a new object. So just like for primitive types, Python will create a new object whenever you try to modify primitive types. But for reference types, Python will not create a new object. It will modify the existing one. So operations on mutable objects modify the object itself rather than creating a new one. Rather than creating a new one, it will modify the existing one. Okay. So common reference types in Python, we have lists, all right? We have dictionaries, we have sets, we have user-defined objects like classes, instances of classes. Okay, so these are reference types. So whenever you're creating objects of these types, know that whenever you modify them, you will be modifying the original copy. All right, Python will not create any new copy of them. Python will modify the original copy. All right, so now examples of mutability. Now let's do the same thing we did before. We are creating an array here and we are printing, sorry, not array, list. I'm so sorry. All right, array is for JavaScript. So we are creating an array here. Sorry, we are creating a list here and we are printing the ID. Then we also modify it by calling the append method, and we also print the ID. So let's go to code and see. Now we have seen this, we have seen that the primitive types, whenever you modify them, Python will create a new object. So let's go for reference types. So I'm going to create 1, 2, 3, 4. All right. And then I'm going to print the ID. I'm going to print the ID of this object. Oops, sorry, not A. Not S, it's A. So then I will say F first ID. First ID is this. First ID is this. And then I will now say a.append. I want to append 5 to it. That means I'm modifying it. So I will now come again and now print second ID. So we are going to see that both the first ID and the second ID are going to be the same. Python did not create any new object. So it was modifying the original object it has in memory. So I'm just going to clear this. And then I'll run Python script .py. Okay, now check. You see, first ID is this. They are both the same. You understand, all right? It is not like the primitive type whereby when we try to modify the first object that was created, Python will create a new one. In this case, Python does not create a new one. So we are still working with the previous object. That is why they have the same identity. So you can see there was no change. So whenever you're working with primitive types, understand that any change you make to the original copy will be affected. Any change you make, it will affect the original copy. All right. So because they are all working on the same objects, but for primitive types, they are not working on the same object. Python will create a new object for it. All right. If you create a dictionary, all right, and also modify the dictionary, you will get the same address because both of them are all reference types. So Python doesn't create any new object for them. So why is mutability important? It saves memory when you're updating large objects. Remember that when Python is modifying a primitive object, it is creating a new object. All right. Just imagine that if it's doing that, more objects will be created in memory. Now imagine that we don't have reference types and you want to modify reference types, large objects. Lists can have millions of items in them. So imagine that when you're doing that, if Python keeps on creating new objects in the memory, your memory will get full. So this saves us memory because Python is just modifying the same. Python has just one object that it is working with. It doesn't create any new object when you modify the reference object. It can lead to unexpected behavior when multiple variables reference the same object. So you have to be very careful. Okay? When you have multiple variables referencing the same object, it can give you unexpected behavior. Let me show you what we mean by this. Okay? Now I have A as a list. If I try to say, look at it. If I try to say B is equal to A, what am I doing here? What am I doing here? I'm just copying the reference of A to B. That means B and A are pointing to the same object now. If I go on and print, if I go on and print, I will say B, I will say B's ID. All right. If I go on and print the ID of B, it's going to be the same thing. Okay, it's going to be the same. I'm just going to use this thing to demarcate them. All right. It's going to be, both B and A will be pointing to the same object. So if I try to do this, you can see that A has this object. When we also modify it, it has this object. And B also has the same object. It means that if you try to modify B, in any way, if it's not say B dot append, you're modifying the same object. That means you'll be also modifying A. Because both of them are pointing to the same object in memory. If you now modify B, you will be modifying A at the same time. So if I go on now, I modified B, and if I go on now to print A, I'm now going to see that 6 has been appended to A. Meanwhile, I didn't modify A directly. I didn't modify A directly. Look at it. I'm only having a reference. I have A, and I'm saying B is equal to A. That means I'm passing the ID of A to B. So if I go on and modify B, I'm also modifying A because the two of them are pointing to the same location. You and your roommates, you have the same address. If the police comes for you and they don't see you, they carry your roommate, something like that. So if I modify B, I'm also modifying A indirectly because both of them are pointing in the same direction. I'm modifying the same location. So if I go on and save this code and run it, let me clear first, you will see what we have here. Oops. Look at it. I did not modify A, but I am printing A. All right. I didn't add 6 to A. I didn't append 6 to A, but look at what A got us. So I modified B, but that modification affected A because both of them are pointing to the same memory location. So that is it. Be careful when you work with it. This is called reference types because you're passing a reference. When I say B is equal to A, I'm actually passing a reference of A to B. So I'm saying A has a roommate. So both of them are living in the same memory location. So anything you do to B will affect A. Anything you do to A will affect B. All right? So I hope you get that. So it requires careful management, especially in functions. So there's something we call passing arguments by value and passing argument by reference. So I'm also going to explain it here. So, but I need you to understand all the things we have talked about here. We have talked about primitive types, why they are immutable and what it means for them to be mutable. We have talked about mutable types, which is the reference types, why they are mutable and why we should have them as mutable. And when you actually pass in a reference of a particular reference type to another one, you actually be modifying them indirectly. So what does it mean to pass by reference and to pass by value in functions? So although we haven't talked about functions, all right, but let me still explain this. We'll still talk about it when we talk about functions. Primitive types are passed by value. What we mean is this. When you pass a primitive type as a function argument, you're passing a new copy. Changing them inside a function doesn't affect the original one. Look at it. Remember, when you try to modify a primitive object, Python will create a new object. So if you pass a primitive, if you pass an integer, a float, a boolean, a string, or a tuple to a function, you're passing them by value. We call it that you're passing them by value. You can either pass arguments by value or by reference. So when you pass by value, it happens basically when you pass primitive types as arguments. If you change that value in the function, it will not affect the original one. So let me show you. Reference types are passed by reference. That means when you modify this reference object in a function, it will affect the original copy. So let's do an example here. In as much as you don't understand what function is, I'm still going to explain this. Don't worry, we'll talk about functions later. So look at, I have a function. This function calls modify primitive, and it is taking a primitive type as a parameter. And inside of it, we are modifying this primitive type. So let me just go on and write this function. Okay? Let me just go on and write this function and explain to you. So I'm going to take all these things out. So I'm going to write a simple function. Def, I will say modify primitive. All right? This function is going to take x, which is going to be a primitive type. Then inside of here, I'm going to say x plus equal to 5. That means I'm modifying this s inside here, and I will print, print x. All right, so when I call this function, I'm modifying s and I'm printing x. All right, so now let me go on. I will say num is equal to 5. Then for me to call this function, I'm going to pass in num. Remember that num is a primitive type. Oops, sorry, I'm calling def. I should call modify primitive, and I'm passing num as the argument. Now look at what we are doing here. We created a function, all right? And we are passing a primitive data type to it. And inside of this function, we are modifying it. And as we are modifying it, we are also printing the value. Now, you might think that since we have this variable number equals to 5, since we have this object, and the object is what we are passing to this primitive type, so this function, as we modify it inside of this function, it is also going to affect the value of num, but that's not the case. So look at what is going to happen. I'm going to print another line, and I will just use this to demarcate them. So remember, if I call this function, it will modify the primitive, the x, which is the number that I've given here, and it will also print it out. So let me also go on and print, I will say f num, then I would print num. So you're going to see that it wouldn't change. If I save, I'll clear my terminal. If I look at it, you see, we passed in this num into this function, and inside this function, we modified it. But after modifying it, our num still didn't change. Why? Because it is a primitive type, and when you pass a primitive type to a function, you are passing it by value. And when you pass an object or data if you pass it by value to a function, anything you do inside the function will not affect the original copy. So the original copy here is the num, and we are passing it to this function, and this function modified it, but it didn't affect the original copy. That is why you saw we have 10 here, printed that after the modification, but the num itself, the original copy didn't change. So this is how it works. When you're passing primitive data types to functions, all right, if you modify them inside the function, it doesn't affect the original copy. So this is called passing arguments by value. All right, so let's take a look at passing by reference. If I do the same thing, and I will say, instead of modify value, I will say modify reference. Okay, and this s is just going to be list. It's going to be a list. So in here, I will now say s dot append. I will append 5 to it. Then I will have this num to be a list 1, 2, 3, 4. All right, and we no longer have modify primitive. We now have modify reference. So now look at it. So this time around, I am passing this thing by reference because I'm going to be passing a list. Remember, a list is a reference data type. So if I modify this data type inside of my function, the original copy will be affected. So look at the original copy. The original copy, we do not have 5. We only have 1, 2, 3, 4. And inside of it, we are appending 5 to 8. So if I run this code now, look at what we are going to get. All right, it's going to affect the original copy. So if I print X inside of the function, it will give us 1, 2, 3, 4, 5. And if I also print the num, it will also get the same thing. So it affected it. So you can see the original copy is this, and the one that we got inside the function is this. So when you pass reference types to functions, if you modify them inside a function, it will affect the original copy. So I hope you understand what was taught in this. And in case you have any confusion, please reach out to us. I just showed you an example of how you can actually modify pass by reference. So if you pass a reference value to a function, and inside the function you're modifying it, you will actually modify the original copy because Python is not creating a new copy. Okay, so this is very, very easy to understand. And best practices, use immutable types when you're creating constant data. When you have data that are not going to change over the course of your program, use immutable types. Strings, integers, tuples are preferred when data shouldn't change. So whenever you have data that will not be changing in your program, you use immutable types because you will not be changing them. All right. Be cautious with mutability, especially when you're working with when you're you're assigning a reference type to another reference type, because any changes you make to the other one will be affected. So avoid unexpected changes by making deep copies when necessary. So in the next session, we'll talk about shallow and deep copying of lists. Basically, that is the reason why we actually have to teach you primitive and reference types so that you understand the session in shallow and deep copying. So use mutable types for dynamic structures. Lists and dictionaries are ideal for data that will be updated frequently. When you have data that will be updated frequently, use lists and dictionaries. When you have data that will not be updated frequently, use tuples, strings, integers, floats, and booleans, okay? So thank you very much. Do your assignments, do your tests, and if you get confused, if you don't understand anything, please reach out. Our WhatsApp is always available. Thank you very much, and I'll see you in the next section.